Hello everyone, this is the Simple Math Tutor, and today we're going to be going over completing the square as a method of solving quadratic equations. It's a method that comes in handy a lot, especially on the SAT, where there's certain problems like circle equation solving and finding the vertex form of a quadratic equation that you need it for. I'll be making future videos on those types of problems later. So first we're going to start with what we have, the general form quadratic equation, right? Something we should all be familiar with. So the first step towards completing the square is you want to get rid of whatever the coefficient term of x squared is. So in this case, the best way to do that would just be to divide by a. So I'll have x squared plus b for ax plus c over a equals 0. And the next step, and this is the step that kind of confuses people, so I'll try my best to explain it. But essentially, we're going to be trying to rewrite this in a form of a perfect square. That is to say, we want to factor it in a form where we have x plus some constant or some number squared, right? And how do we want to do that? Well, the formula for it is very simply taking this term that's a coefficient to the x, halving it, so dividing by 2, and then squaring our result. So in this case, we'll be adding b squared over 4a squared. Well, why does this work? Well, if we look at the factored form of a polynomial, or of a, rather this x plus a squared, right? When we factor it out, we'll be left with x squared plus 2ax plus a squared, right? And if you notice, this term, the coefficient of the x, is always what? This is 2a. Well, if you take half of 2a, or just a, and you square it, you'll be left with the constant that you can use to complete the square. So that's why it works. Hopefully that'll help it stick a little better if you have trouble remembering it, but otherwise it's just b over 2a squared, right? The coefficient of the x term squared. So what I'm going to want to do is I'm going to want to add that in, plus b squared 4a squared, right? And of course, I can't just simply add a value that I choose to an equation, right? I need to make sure I balance it. So I can either add it to the other side, or I can just subtract it again from this side. A minus b squared over 4a squared, right? So now I'm adding this term, but I'm also subtracting it. So my total, what I'm adding in total to the equation is 0, right? So it works out. So now, because I added something that allows me to complete the square, I can simply factor this nicely. So I'll have x plus b over 2a squared, right? Because b over 2a will multiply out to b squared over 4a squared, and will add to the ba, that's the coefficient of the x term, right? And now I'm also going to move this to my other side, and you'll see why I'm doing that in just a second. So I'll have b squared over 4a squared minus c over a. Well, first off, let me try to see if I can combine these, right? Well, to combine, I just need the denominators to be the same. So I can just multiply the top and the bottom by 4a. So this will become a squared, and multiply the top by 4a. So I'll write 4a up here, right? So now if you start to notice, this is starting to look a lot like the quadratic formula. But let's see. First, let me combine these terms, right? The same base, so I can simply write this. And now I can just rewrite this as the one denominator, b squared minus 4ac all over 2a, right? Excuse me, it's supposed to be 4a squared. My mistake. So we have over 4a squared. I kind of jumped a step there. So now what we want to do is we want to get rid of this power of 2. So we'll take the square root of both sides. So we have x plus b over 2a, and that's going to equal, can't really work with, take the square root of this top term, so we'll just leave it as a square root of b squared minus 4ac, and then we'll take the square root of the bottom term, and we'll get 2a. So now this should really start to look familiar, because now all I have to do is move this b over 2a to the other side. So I'll have a minus b, and the denominator is the same, right? And excuse me, when we're taking the square root, we should have plus or minus because we're taking the square root of a variable. So we have opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. And this is the quadratic formula. So as you can see, the quadratic formula is derived directly from completing the square. So you might be wondering, well, what's the point of knowing how to complete the square if I can just plug it into the formula? And the answer is it does come in handy with certain questions, like finding equations of circles, finding the vertex form of quadratic, stuff that comes up on the SAT frequently. So now I'm going to give an example, just so you guys have something with more numbers to work with, if that's more your speed. Plus 3 equals 1. Right. So now, first thing I want to do is I want to get rid of the coefficient of x squared, because it doesn't work when there's a coefficient there. And it just will make it a lot simpler to work with. 1. So I'm going to subtract 1 from both sides. Well, to make this a better example, let me actually get rid of the 1 that's on this side, because that will just make it too easy to solve. Won't even have to worry about factoring it. So instead, I'm going to write 0 up here. And when I subtract the 1, I'll get a negative 1. Jumped a step. We have 0 minus 1. Now, if I want to complete the square, I take half of this term and square it, which will just come out to be 4, because 2 squared is 4. And I want to add that to this side. I can either subtract that 4 from this side or add it to this side. Either way, I'll be able to balance my equation. So now, well, what does this become? This, we know, will be a perfect square of just x plus 2 squared. And that's going to have to equal 3. From here, we simply take the square root of both sides, plus or minus the square root of 3, and we subtract 2. So we have negative 2 plus or minus the square root of 3 for our final answer. Not a super neat answer, but hopefully it'll give you a good example of how completing the square works when you're working with actual numbers. And that'll be about it for today's video. I hope you guys found it helpful. Please leave a like, comment, subscribe, do whatever you can to interact. And I'll see you in the next one. Bye-bye.